There's something happening inside your arteries right now that your doctor probably isn't talking to you about, not because they don't care, but because the entire conversation about heart disease has been focused on the wrong thing for the last 50 years. We've been told it's about cholesterol. We've been told to avoid fat, avoid red meat, and take a statin. But here's what's wild. A massive UCLA study looked at over 135,000 people who had heart attacks, and 75% of them had completely normal LDL cholesterol. So if cholesterol was really the problem, how do you explain that? Today, I want to walk you through what's actually happening upstream, before the plaque, before the symptoms, before the heart attack, and more importantly, what you can eat starting today to slow this process down, stabilize it, and in many cases, actually reverse it. Let me start with the basics of how plaque actually forms. Because if you understand this chain of events, everything else is going to make a lot more sense. Inside every artery in your body, there's a very thin, incredibly delicate layer of cells called the endothelium. It's essentially just one cell thick, and this layer does an enormous amount of work. It controls blood pressure, prevents clotting, acts as a filter, and produces something called nitric oxide, which is a signaling molecule that keeps your arteries relaxed, flexible, and open. Think of the endothelium like the non-stick coating on the inside of a pipe. When it's intact and healthy, blood flows through smoothly and nothing sticks. Now, what damages this coating? Chronic high blood sugar is one of the biggest ones. Every time your blood sugar spikes, especially above 140 milligrams per deciliter, it's like dragging sandpaper across that inner lining. And if this is happening twice a day, 3 times a day, every day for years, that's an enormous amount of accumulated damage. Smoking does it, chronic stress does it. Seed oils, canola, soybean, corn oil, do it. Refined carbohydrates do it. Even gluten can irritate that layer in sensitive individuals. The common thread is chronic, repeated exposure. One bad meal doesn't build plaque. A lifetime of bad meals does. So once that endothelial lining is damaged, what happens next? Your body recognizes the injury and sends in a repair crew. Inflammation is triggered. White blood cells, specifically macrophages, rush to the damaged area. And this is where cholesterol gets pulled into the story. LDL cholesterol particles start slipping through that damaged wall. Now here's where most people get confused, because not all LDL is the same. There are 2 types. There's large, buoyant LDL. These float through your arteries without causing problems. Then there's small, dense LDL. These are small enough to get trapped inside the damaged arterial wall. And once trapped, they get oxidized. They become what we call oxidized LDL, and that is genuinely inflammatory and dangerous. Now your macrophages, your immune cells, come in to clean up the mess. They start eating this oxidized LDL. The problem is they don't know when to stop. They keep eating and eating until they become these bloated, foam-filled cells called foam cells. Under a microscope, it looks like foam, which is why the name stuck. These foam cells die over time. And underneath the cap of a soft plaque lesion, what you have is essentially a graveyard of dead immune cells, calcium, oxidized cholesterol, and fibrous tissue all packed together. That's the plaque. And here's the critical thing people don't understand. There are 2 types of plaque too. There's soft plaque, which is unstable, dangerous, and prone to rupturing. And there's hard, calcified plaque, which is more stable and actually less likely to cause an acute problem. The irony is that when a heart attack happens, it usually isn't caused by a massive blockage. It's caused by a small, soft plaque, sometimes only blocking 20% of the artery, that suddenly ruptures. The rupture triggers a massive clotting response, and it's that clot that actually causes the heart attack. So the game isn't just about reducing blockage. The game is about stabilizing these soft, vulnerable plaques before they rupture. And that is where food becomes so powerful and where statins alone are falling short. Now I want to talk about what causes the small, dense LDL to form in the first place, because this is the missing upstream piece. When you eat excess carbohydrates, especially refined, processed carbohydrates, your liver converts the overflow into triglycerides. Your liver gets overloaded. And when triglyceride levels in the blood are high, your body starts producing more of those small, dense LDL particles. The particles hang around longer in the bloodstream. They get oxidized, they trigger an immune response, and the cycle begins. So at the root of this whole problem is chronically high insulin, chronically high blood sugar, and a liver that's overloaded with triglycerides from too many carbs. That's the upstream cause. Everything else, the LDL, the foam cells, the plaque, that's all downstream. Here's why this matters. If you go to your doctor and your LDL is high, they put you on a statin. Statins do lower LDL, but they don't address the root cause. They don't fix the endothelial damage. They don't reduce the insulin resistance. They don't eliminate the oxidized, small, dense LDL particles that are actually doing the damage. And statins also block something called coenzyme Q10, a critical nutrient for your mitochondria and your heart muscle itself. There's also a research concern worth noting. Some of the most widely cited statin safety studies have not released their raw data despite years of requests. These same research groups have received hundreds of millions of dollars from pharmaceutical companies, and the studies use something called a run-in period, where people who had bad reactions to the drug were removed from the study before the results were even collected. When you screen out the people who react badly and then publish results saying the drug is safe, that's not clean science, that's a filtered result. None of this means statins are useless for everyone. For people at genuinely high cardiovascular risk, they can be a meaningful bridge, but they're being sold as the solution when they're really just managing one downstream symptom of a much deeper problem. So what do we do instead? Let's talk food, and I'm not going to give you a magic superfood list. I'm going to explain the mechanisms, why certain foods help, so you can actually understand what you're doing and apply it for the rest of your life. The first thing to understand is insulin. Your endothelial cells, the ones lining your arteries, actually prefer glucose as their primary fuel, but they need insulin to use it. When you have insulin resistance, which the majority of people have to some degree, that layer isn't getting properly fueled. It breaks down. It becomes vulnerable. So one of the most powerful things you can do for your arteries is reduce insulin resistance. And the most direct way to do that is eat fewer refined carbohydrates and practice intermittent fasting. Intermittent fasting gives your insulin levels time to drop all the way down. It reduces inflammation. It allows the body to start clearing damaged cells and repairing tissue. Now let's get into specific foods. Omega-3 fatty acids are foundational. Wild-caught salmon, sardines, mackerel. These are rich in EPA and DHA, which calm the immune response that aggravates plaques. Omega-3s also help your arteries produce more nitric oxide, which keeps them relaxed and flexible. The MESA trial, one of the longest-running heart disease studies, found that higher DHA levels were associated with a 12% lower risk of plaque progression in the carotid arteries. If you can't eat fatty fish regularly, cod liver oil is an excellent option because it also provides vitamins A and D. Speaking of nitric oxide, let's spend a moment here because most people don't understand how important this molecule is. Nitric oxide is your body's natural vasodilator. It keeps arteries open, it prevents them from stiffening, it stabilizes plaques, and it's directly produced by a healthy endothelium. Dark leafy greens, especially arugula, kale, and spinach, are loaded with dietary nitrates, which your body converts into nitric oxide. A single serving of raw arugula can meaningfully spike your nitric oxide production. This is vascular medicine you're growing in your salad bowl. Magnesium is another critical player here. Magnesium triggers nitric oxide production. It relaxes muscle spasms, lowers cortisol, and critically, it helps keep calcium from depositing inside the arteries. Most people are chronically deficient in magnesium, and this deficiency shows up directly in cardiovascular risk. Spinach, almonds, and pumpkin seeds are all excellent sources. Now let's talk about vitamin K2, because this is one of the most underappreciated nutrients in all of cardiovascular health. Vitamin K2 controls a protein that keeps calcium from building up in soft tissues, including your arteries. Without enough K2, calcium that should be going to your bones starts accumulating inside your arterial walls instead. And here's what's wild. Mainstream dietary advice for decades has been to avoid the very foods richest in K2. Fatty cheeses, especially aged hard cheeses like authentic Parmigiano Reggiano, the real kind from Italy, not the craft version with cellulose filler, are loaded with K2. Fatty fermented meats contain it, egg yolks contain it, and your own gut microbiome makes K2 when it's healthy, by converting vitamin K1 from leafy greens. Which brings me to something most heart disease conversations completely skip over: the gut microbiome. Research using germ-free animals raised without any gut bacteria, shows they develop serious cardiovascular problems, underdeveloped hearts, low cardiac output, widespread inflammation. When you destroy the microbiome, whether in a mouse or a human, systemic inflammation goes up, and inflammation is the trigger for everything that goes wrong in your arteries. Your gut bacteria, when healthy and well-fed with fiber, produce short-chain fatty acids, specifically acetate, propionate, and butyrate. These molecules do something remarkable. They lower LDL cholesterol, reduce systemic inflammation, improve insulin sensitivity, and may even stimulate the growth of new blood vessels that help route around blockages. Fiber from lentils, chickpeas, oats, vegetables, and whole plant foods feeds this process. But there's another layer: fermented foods. Sauerkraut, for example, is a nutritional powerhouse for the heart that nobody talks about. It's loaded with lactic acid bacteria, a group of microbes that can act like an ACE inhibitor to lower blood pressure, inhibit biofilms in the arteries, regulate small, dense LDL, and enhance the absorption of fat-soluble vitamins, including K2, D, and E. It contains roughly 7 times the daily requirement of vitamin C per cup. Vitamin C, by the way, is essential for maintaining the integrity of the arterial wall, collagen synthesis, antioxidant protection, and directly inhibiting the formation of microbial biofilms that can take hold in rough, inflamed arterial tissue. Here's something particularly fascinating. Researchers have found pathogens, including chlamydia and H. pylori, living inside arterial plaque. The arteries are not the sterile environment we once thought. There is a microbial community living there, and the quality of that community is influenced by the quality of your gut microbiome and the extent to which you're eating living, fermented, microbially rich foods versus sterilized, pasteurized, shelf-stable processed food that your gut bacteria can't work with. So part of what you're doing when you eat sauerkraut or real fermented cheese or raw vegetables grown in healthy soil is re-inoculating your gut and your body with beneficial microbes that are directly protective against arterial disease. Let's also talk about vitamin E. This is another seriously under-discussed nutrient in arterial health. Vitamin E is a powerful fat-soluble antioxidant that protects the endothelial lining from oxidative damage, the kind of oxidation that turns LDL dangerous. It's also important for heart muscle function and oxygen delivery, and one of the primary things that depletes your vitamin E: refined grains, white flour, the enriched bread and pasta that nutritional guidelines have been recommending as heart-healthy for decades, is depleting one of the key nutrients your arteries depend on. Sunflower seeds and pumpkin seeds are excellent sources of vitamin E and magnesium, respectively. Adding them to a salad is genuinely therapeutic. Now, let's talk about the one supplement that actually has strong randomized controlled trial evidence behind it for arterial plaque: aged garlic extract. 2 separate randomized controlled trials have shown that aged garlic, at around 2,400 milligrams per day, can actually reduce soft plaque. Not just stabilize it, reduce it. One study used angiogram imaging to confirm this. Another showed that the group taking aged garlic had lower progression of coronary artery calcification over 1 year, along with improved blood pressure. Aged garlic is also an antioxidant, helps thin the blood slightly, and lowers blood pressure moderately. If you're on blood-thinning medication, check with your doctor first. Regular crushed garlic is excellent for blood pressure and antimicrobial effects, but the aged extract specifically appears to have the unique ability to address soft plaque. What about exercise? Exercise increases nitric oxide production, especially outdoor exercise in sunlight, which also stimulates vitamin D, another potent anti-inflammatory and nitric oxide trigger. There was a randomized controlled study published in the European Journal of Preventive Cardiology showing that 6 months of high-intensity interval training produced a significant reduction in plaque volume, actually slightly greater than what they see with statin intervention in comparable timelines. That's a remarkable finding. It doesn't replace medication for everyone, but it tells you exactly how powerful consistent exercise is. I also want to mention extra virgin olive oil, real extra virgin, from a producer that actually cares. Olive oil is rich in polyphenols and monounsaturated fats that are anti-inflammatory and protective of the endothelial lining. High intake is associated with meaningful reductions in major cardiovascular events. It also supports insulin sensitivity, which feeds back into reducing the upstream cause of all of this. Put it on everything. Now, what to avoid. I'll keep this brief because the mechanism should be obvious by now. Refined carbohydrates, pastries, cereals, bread made from white flour, granola bars dressed up in healthy packaging, fruit juices with no fiber, all of these spike blood sugar, elevate triglycerides, drive small dense LDL production, and damage the endothelium. Flavored yogurts are often loaded with added sugar. Buy plain full fat instead. Most breakfast cereals are functionally dessert. Read the labels. Seed oils, canola, soy, corn, cottonseed are highly inflammatory. They compete with omega-3 fatty acids in your body, and the balance matters enormously. And if you want a simple test to run at home, get a basic blood glucose monitor from any pharmacy. Check your blood sugar about 30 minutes and then 2 hours after your meals. Your peak should stay under 140 milligrams per deciliter. If it's consistently going above that, silently, invisibly, twice a day, that is what is damaging your arteries, not your fasting number. What happens in the hours after you eat? Let me put together the core framework in plain language. First, fix the upstream cause. Reduce insulin resistance by cutting refined carbohydrates and incorporating intermittent fasting. This is the root. Without this step, everything else is damage control. Second, Protect and restore the endothelium. Nitric oxide is the key molecule. Get it from leafy greens, exercise, sunlight, and magnesium. Third, crowd out the small, dense LDL. Eat more phytosterols from nuts, seeds, and legumes. Reduce triglyceride-generating carbs. Eat more fiber from whole plant foods. Feed your gut microbiome. Fourth, reduce oxidative stress. Omega-3 fatty acids, extra virgin olive oil, vitamin E from seeds, lycopene from cooked tomatoes, flavonoids from berries, dark chocolate, and green tea. These compounds directly intercept the oxidation process that turns LDL dangerous. Fifth, keep calcium where it belongs. Vitamin K2 from fermented foods and fatty cheese. Magnesium. Vitamin D3. These three work together to keep calcium in your bones and out of your arteries. Sixth, stabilize existing soft plaque. Aged garlic extract, fish oil, consistent exercise, and if your doctor has put you on medication, don't stop. Use the food and lifestyle changes as a complement, not a replacement. And seventh, eat living food, sauerkraut, real fermented cheese, raw vegetables, foods that haven't been sterilized, pasteurized, or processed into nutritional oblivion. Your microbiome is your cardiovascular system's silent partner. Take care of it. This isn't complicated once you understand the chain of events. Heart disease doesn't start in your arteries. It starts upstream, in your diet, your insulin levels, your inflammation, your microbiome. By the time the plaque is visible on a scan, the problem has been building for 10, 20, sometimes 30 years. The good news is, the same mechanisms that build it can be turned around. Not overnight, but consistently, measurably, over months and years. And if you want to understand exactly how to structure the ketogenic diet and intermittent fasting to take this even further, the next video I'd watch is the one on how to do a healthy version of keto with intermittent fasting. It's the logical next step from everything we just covered. Check it out.